right, good evening. Can you hear me? Hello?
Yep, we can hear you.
Yeah.
Oh, okay, very good. So, let me see. So make sure you mute yourself. Okay. So has everyone submitted homework?
I thought it was due at midnight tonight.
Oh, that's fine, yeah. So
Okay.
I was thinking, the reason why I ask you, because I was thinking, so maybe give you a few more days, because this is not easy homework. And plus, we are in a remote learning, so I may not able to answer your question properly, because with email. So I guess probably it's fair to give you maybe 2 days, if you don't mind. So why not just submit by the end of Wednesday, if you wish. But if you are ready, just submit. Is that okay?
Yes, thank you so much.
Yeah. So in the meantime, just feel free to send me emails, or if you want, you can just Zoom in, because like in the afternoon. So there's one student, so we set up a Zoom meeting, and I answer the student questions. I hope I answered all of her questions. So maybe, okay, before we start today's class, let me just quickly walk you through for the exam. Sorry, not the exam. So walk you through quickly with homework. So make sure. Okay, so now I'll switch my other monitors. Okay, so let me just quickly walk you through with the homework. Okay, and again, so if you need extra time, just submit the stuff by the end of Wednesday. All right. So I guess question 1 is pretty straightforward, right? So, but there I still got question for question 1. So here, the tricky part is, I mean, it's 2 part. I would have said probably like 3. So number 1, you need to find a GMP, right? So maybe, so it's difficult to find a GMP. So if you can find, I think so. We talked about that last week. So you can use GNI. Or if you still cannot get GNI, maybe you can use GDP. That's fine. This is the first. And secondly, so you need to find a real, not a nominal. This is second. And the third, so real is not enough. So you need to make sure you need to find the real GMP and with a common currency. And why we need that is just make sure we can compare one country's GMP versus the other, right? So make sure so we are comparing apple versus apple, not apple versus pear, right? So there are 3 things. Number 1, use GMP. Number 2, return. Number 3, use a common currency, right? So in terms of common currency, so there are a bunch of options, but the best measure is use purchasing power parity, right? So this is for question 1. Now go to question 2. Okay, so let's go one by one. As I just explained last class, you can just pick whatever country you feel you're interested in. Right? So not necessarily you have to work on those 4 countries, but ideally, yes, I want you to do these 4 countries. Okay, now go to part 1. So here when I say t equal to 1980 to 2010, let's just say from year 1980 to 2010. So I want you to find out data for each individual years. Okay, not only 1980 or 2010. All right, so you need to find out data for each years, but I understand so you may not get all data. So you may start with 1990. All right, so that's okay. And then, so for the data for capital stock, it seems like straightforward, right? And then for labor supply, let me just maybe just tap here. So labor supply, so essentially you need the 3 data to finish this part. Okay, first you need to find an employment population ratio. Second, you need to find a population. Third, you need to find out hours worked per worker. Okay, so if you multiply them all together, you're going to find out the total hours worked in that country. So that's going to be used to measure labor supply. For real GDP, that's straightforward, right? Okay, this is A.
Professor,
So
can I
once
ask a question?
yes.
Okay, can you explain like how you're grading them? Because like when I went through the labor supply, like China doesn't provide any data on hours worked per person or like per employee. And so like I went through all the formulas and then realized if I didn't have that, I like couldn't complete the rest. So like, is that okay? Or how do you, like, do I have to go
It is
back
okay.
and pick a different country?
So it's absolutely okay. So the point of this exercise is for you to have a sense how we are going to work with data. Right? So if you cannot find sensible data for China, feel free to switch to whatever country you'll feel interesting. But again, so the reason why I picked those countries is because that's very relevant for us to understand economic growth. But if you really have trouble to find a more comprehensive data for either one of those countries, feel free to switch to the other country. But make sure you understand what you're doing. So that's the point.
Okay.
Okay. So make sure you understand this part, right? So, but certainly you have other ways to calculate hours work, but this is just one way, depending on your data availability.
Hey, Dr. Fang, one more quick question.
Yes.
I sent you an email, but just wanted to like get a sense of how you're going to grade this. So when I found all my labor data on the Fred website, it was all from 1991. It didn't go back as far as 1980.
That's okay.
So I just assumed 1991, I just assumed it was 1980. So I think
Whoa.
I executed everything correctly, but.
No, wait. So, okay. So this is very important. Okay. So do not assume 1991 is 1980. Just never do that assumption. It just pretend what you have from the data. That's okay. So if you have if you only have data start from 1991, or even you only have data start from 2001, that's okay. Okay, do not change that part. Just present whatever you find. Does that answer your question?
Gotcha. So I guess the best way to do it would just try to change all my variables to start at 1991 so it's consistent, as opposed to using variables beginning in 1980 and 1991.
Right.
Gotcha. Okay, that makes sense.
Okay. Okay, so once you find the data, right? So essentially, so in the data, you should have an Excel file, right? So I can pretend I have Excel. So what you have is country here. So the first column and then second column, so you calculate your labor or capital. And then third column, you calculate labor. And then, so the last column, you calculate your Y, right? So this is what you're supposed to get. Or wait a second, so you need to have years. Right, so this is your data, how your data will look like. All right, so this is how your data look like. And then, so this is part A. So essentially, this is for each country. So for example, you start with China. So ideally, you have China. And then, so you have 1980. And then, so you have China. And then 1981, right? So on and so forth. Okay? And then there's one, at least the two students asked me how to calculate growth rate. So this actually refers to the part C, but I guess I can explain to you right away. So the way you do that is, so essentially you use this row to divide it by this row. So that's going to give you the growth rate in Excel. All right, so essentially you create like a new row. So for example, here you could create another column, growth rate of K, and then growth rate of L, and the growth rate of Y, right? And then so the GK, so this column is going to be defined by, so this row divided by this row, and so on and so forth. Okay, so there should be some trick to do that in Excel. So now once you gather your data, so this is the most important part. Okay, so once you gather your data, like say, for example, one student just mentioned, so you only have data from 1991, and then start everything from 1991. Okay. And then, so, okay, once you have data, and then you calculate TFP. So how you going to calculate TFP? Just follow this formula. Okay, so first you need to make sure you understand what this means. Where does this coming from? So this is what we explained last class, right? Okay. And the second is make sure so you do this correctly, and then so you're going to easily run into a problem. This is a common question I received from our previous students. So depending on what unit you use, you're going to get a different TFP, right? So if example is here, so if Y is if Y is like $1 billion, L is hours and K is dollars, versus Y is like $1,000. L is again, so L typically is hours and K, but it's like $1 billion, and that's you're going to get different unit, right? But there's I want to tell you, so TFP, for TFP, really there's no unit. Right? It's a unit free. Why? Because here's Y, and on top is like less like $1, and the K is also like $1. So so basically, so essentially the dollar divided by dollar. Okay, this is like there's no unit. And also TFP itself isn't very useful. I mean, for a single country. Okay, so when TFP starts useful is when you calculate the TFP growth rate, or if you just use the same unit to compare one country's TFP versus the other country's TFP. So that starts to make sense, or start to meaningful. If you only look at one country's TFP, so whether it's 3 or the 3,000, doesn't tell you much. You can easily end up with like 3 or 3,000, right? Depending on how you use your unit. Are you with me? Do you understand my point? Hello? Any response? Do you understand my point? Anyone?
So K gets raised to 0.33, correct?
Yes.
So it's your GDP divided by your capital that's raised to 0.33 times your labor, right? That's
right.
The entire formula.
Yeah. So
for some reason when I did that factor, I did not get like a percentage. I got like a big number.
So that's exactly what I was trying to explain to you. Get a big number is fine. If you don't mind, so can you just share your screen so I can explain to you and to the class?
Yeah, I can. Can you just
okay,
stop
so
sharing
share right
for
now.
1 second?
Okay, so let me just stop sharing. All right, so let me see where you are. Okay, so this is India. Okay, let's just go one by one. Okay, so and what Jordan? So she has is D is year, and column E is what is that? Column E is what? Can you give us the entire picture of the data?
Yeah, 1 second. I'm trying to figure out how to.
Just move to the left. We want to see column A.
Okay, sorry. I was trying to unmute myself so I could explain what I did. Okay. So mine pulls from different sheets. So my capital stock's on this sheet.
Oh, I see. Okay, so now let me first just show us. Okay, so like India, 1980. So you have this number, right? So this number most likely is probably like $1,000, right?
Yeah. So I was in a similar boat where like the capital labor didn't start till like 1991. So on this, I just hid all those other like all these rows didn't have any data, so I hid them.
Oh, okay.
Like some of the other students were just saying that it didn't start, so.
That's fine. Start with 1991, that's fine. So now explain to me how you get E. Okay, so now let me see, you get E. E is So GDP, what does this,
So GDP is on this for each
Right.
one, and then I divide it by capital stock raised to the 0.33 and then labor supply.
now what is the symbol right after GDP means?
That's just referencing the cell.
Oh, I see. Okay, so that,
So,
okay.
yeah, so since we started in the year down here, you can't see it, 1990.
Right, that's fine. So go back to TFB. Go back to TFB. So I think so you are in the right track. So let me just see the formula. So the formula says, are you sure your formula? So you probably miss parentheses. So you need to GDP divided by capital stock raised to the power of 0.33 times labor supply times the power of 0.64. So you need to have a big parentheses. No, so after the slash sign.
Oh, okay.
Right. Right.
Oh, there we go.
But why you get 0?
Oh.
Mine was coming up with 0 too for all of them.
Me too.
But then, so let me see. So you got the same thing. So, but why is that?
Hit the decimal button so you can see all the digits.
Oh, it's too small. The number is.
Won't let me.
Because maybe the number is too small.
Won't let me change it. I don't know why. I mean, I'll mess with it.
No. So okay. So essentially, there's a problem with unit. So you can change the unit.
Well, I don't know.
Decimal place maybe goes to like 10. See.
Yeah, well, it won't let me change it. It's giving me an error right now. Maybe it's because I'm sharing my screen.
All right. But the formula is correct. Oh, now the formula is not correct. Because you're missing the big parentheses. So you need, all right, okay, now it's
Yeah,
correct.
I started it down here.
Okay,
Okay.
but that's fine. So I mean, depending on the unit you have, it could be a very, very tiny number. And it could also be a huge number. But as I
Okay.
just point out, so as I just point out, so the number itself, the absolute value of the number itself, doesn't give us enough information. What matters is you just compare the number from one year to the other year. And then we compare the number from one country to the other country. So that starts to make sense.
Yeah, so
Okay.
I guess my next question would be, since you don't want the Excel like file, do you want like screenshots of it, or how do we show you that we like did it?
Oh, okay, so that's a good question. So maybe you can just give me a what do we call the there's a name for that. So I just need a few rows to you show me so how you get the data.
Okay.
All right, does that make sense? So all right, so now let me just finish the discussion here. So we are here, right? So essentially, so first you make sure you understand this formula. Secondly, you make sure so you understand the unit stuff, right? And then so you may, depending on how you choose the units, you are going to get different numbers. So in that sense, you may want to you may want to choose your unit properly. Say for example, when you use Y, say for example, okay, so it's like $1 billion, and a K, you also must use $1 billion. Now, okay, so if this $1 billion, this kind of like cancel each other close to 1. Now, if L is like, say for example, like 2,000 per year, and then so you're going to get a huge small number, right? So then how you're going to do that? So you may say, okay, this probably I can just convert this instead of 2,000. I say just 2,000, 2.0. Does that make sense? I just give you an example, right? So say for example, you have a TFP, right? And then say for example, one country, I just make up a number, 2.5 trillion, right? And then divided by, say for example, capital is 5 trillion. Raise the power of 0.33. right? And then divided by labor. So for example, labor is 2,000 with the power of 0.66. And then, so you are going to for sure get a very small number, right? Because you're going to divide by something closer to 1,000. So this is not good, right? And then, so a smarter way to do that is you're going to choose the unit property, 2.5 trillion, divided by, so I may just copy paste. And then, so here instead of 2, you said just, sorry, instead of 2,000, you said 2.0. Right? Does it make sense? Are you guys with me?
Yeah, I think so.
Sorry, you said you get or you don't?
No, yeah, I mean, I think I do.
Okay, very good. All
Hey,
right,
Professor, just a quick question. As opposed to getting each year of country data, I just took 2 discrete points and I found the average annual growth rate, and I went that way to calculate my variables. Is that appropriate as well?
can you share me with your screen?
Yeah, I'll do that.
Okay, so maybe you can just do some preparation. Let me just finish this part. Okay, so and then so you can share out with your screen. All right.
Yep.
Okay, so where we are. So now, so this is what I just explained how you calculate TFP. Okay. Once you get TFP, and then so you should be fairly straightforward to find a growth rate, right? Okay, so now what is part D? I think part D is straightforward once you go through the previous step, right? So the hard part is, so I guess hard part is A and B. So you get fairly complete data, and the second you calculate TFP, right? Okay, so please share us with your screen. Let me stop sharing. All right.
Yeah. All right, so I did mine. I just took 2 discrete points, right? So I was just thinking 2010 to 1980. That's what you're seeing here for each country. And then I calculated the average annual growth rates of each variable to figure out at what annual pace were they growing. And then from there, I just set my equation equal this to calculate technology. And then down here, I figured out the contribution of each variable.
Oh, okay. So but this is okay, but you are missing one step. So if you're doing here, so actually part of B. Wait. So you need to find out TFP first.
TFP is right. It's gonna be right here. This is the annual TFP rate.
Oh, I see. But then, so this equal sign just trying to verify. Is that what you're trying to do?
Yeah. I'm just saying. Yep. Our real GDP and the real annual GDP of 7.7% equals this equation multiplied by each other, and then lastly, that's your TFP factor on an annual basis.
No, wait a second. So this gross accounting tells you the number. So the number 7.07 in 10B. So this must equal to 0.33 times 8.27.
Yep.
Plus, no, then plus 0.67 times negative 0.25 and plus 4.551.
Yep. I think it all works out.
Oh, okay. But then, but you need to, but it's just for verify, but it's presumably you should find the TFP growth rate independent of this equation I just explained.
Okay.
So you need to find the TFP first. And then, so the TFP you find out should plug in this equation. So that just should give you, the formula correct.
Okay. Yeah. I mean, I just
wait, does that make sense to you or not?
I mean, not really. The way I calculated the TFP was taking the real GDP divided by, minus all of these multiplied by each other. So I just took the derivative first, and then I just.
Okay, so why not we do the following? So please you send your Excel to me, and so it's Jordan, right? So before this, Jordan, so you send your Excel to me, And so we are going to have a break. During the break, let me just look at your Excel, and then so during the break, I'm going to explain to the class. So how should we proceed?
Okay, sounds good.
Okay, so for now, yes, just take your time. So send your both of you. That was Jordan, right? Is Jordan?
Yeah.
Jimmy.
Yeah.
Jimmy, right? Okay, so both of you send your data to me, and then so over the break, I can just look into your data, and then so I can explain how should we proceed with your data to the class, right?
Okay.
Okay, so now we have to back to our business. Right. Okay, so it means back to our business because we have many things to discuss. Otherwise, so we are going to behind the midterm, right? Because I just realized we are going to have midterm in 2 weeks. All right, where we are. Okay, so I'm not going to review because today we already have to spend like 27 minutes for the homework. So please just review the video online for the material we discussed last class. Now let me just jump into the new stuff in right away. Okay, so this is where we kind of where we left. Right, in last class, so we explained other growth series. Now, so this is a new growth series we're supposed to discuss. Okay, so this growth series is called New Classical Growth Series, right? So it was originally invented by Solo. Okay, and so the starting point of this growth series is a different production function. Just remind you what was a production function. What was the production function we discussed or we saw in Howard-Doma model. Okay, and then the main difference is here. So with the new classical growth model or new classical growth theory, so this production function you have a substitution between K and L. Remember, so in the Howard-Doma, so there's no substitution. So essentially the production function or the isoquant means along this line you have isoquant means along this line you have the same you can produce the same amount of output. So in the Howard-Doma model, you have a perfect complement. It's going to be like this, right? So there's no substitution, meaning so if you have this level of labor, regardless of the capital you're going to have, there's no help, no use. On the other hand, so if you have fixed capital, and regardless how many labor you put, no use, right? So this is Howard-Doma model. But then, so in the Solo growth model, so you can see there is a substitution, right? So you can use capital to substitute for labor and vice versa, right? So this is how the typical production function looks like. This is exactly what we use or what we seen in the homework. Okay, so this is a starting point. Now, oh, right. So I think we already talked about that. So this Solo growth model, the key equation is given by here. Okay. But before that, we already explained the property of the Solo growth model. So essentially, at the end, you can write y equal to, but by the way, y is defined as y divided by L and equal to f k divided by L and L divided by L. But then, so we can easily write this as f of k1, and then we just rewrite this as f of k. Okay, so this is the first equation. And from here to here, or this equality coming from, we call the constant return to scale, CRS, right? And then from here to here, so you just rename, you just label k divided by L as k. And from here to here, we just define, right? So just because this one doesn't make any change or make any difference. Okay, so you end up with y equal to f of k. And here we just assume so everyone is working. Okay, just to simplify, right? And L equal to labor supply, or L at the same time L equal to population, right? So this is one. Now, what this equation tells us is how the capital accumulate over time. Okay? So this delta K means change in capital, right? So there are two ways to change the capital stock, either through saving. S is exogenous given, saving rate times output. Just think about, so you have 10,000, and then so you save 10%, so that's going to increase your capital stock. But at the same time, so we have capital depreciation, okay, DE times K. So what is capital depreciation? Just think about your phone cannot run forever. The house is going to deteriorate over time, right? Okay, and then, so I'm going to skip those things, okay? So if you can work out the math, that'd be perfect. If you cannot, that's okay. So towards the end, so we are going to see this equation, okay? So I'm going to skip the details. But if you really cannot follow the details in the middle, that's okay. So it won't hurt you to understand the big picture. And then where we are end up with this equation, but this is the same. Okay, let's just use this equation as a benchmark to understand, right? So left-hand side delta K, now it's a little k. So little k means per capital. Okay, so this is comparable with this one, but this is per capita. Okay, this is per capita term, how per capita term, capital change over time. So this is going to depend on three things. First, they're positive, there's negative. Positive means increase capital per capita. Saving is times y, right? So this y is per capita. Because the more you save, the more you put in investment, and then so the more capital is going to have. Now, what are the negative, or what factor can reduce capital stock? First, you have depreciation, right? Because your capital is going to worn down, right? So your car is going to deteriorate, the house, the machine, so on and so forth. This one thing, that's obvious. We have another factor is going to reduce per capita capital, which is going to be N. What is N? N is population growth. And remember, in this simple model, everyone works. So if everyone works, L equal to population. And A is the population growth. That's also going to give you the growth rate for labor, right? So now, so this growth in labor or growth in population is going to drag down the capital stock. Why is that? Just imagine, so if we start the economy with one computer, okay, and we have 10 workers. Now, if nothing else changed, but the only population grows, now you have same one computer. Okay, but there's population growth, you have 20 workers. And then immediately you can see, so the population growth is going to dilute, D-I-L-U-T, so apologize if my pronunciation is not correct. It's going to dilute your capital stock, right? So that's why this N is going to drag down the capital. Okay, so now erase everything to highlight what is important in this equation or in this discussion. First, you have Y equal to F of K. Okay, so the other one is delta K equal to SY minus D plus N times K. Right? So how we understand it? Y essentially tells us the level of economic growth, because Y is GDP per capita. It's not a perfect measure, but it's a good measure, right? Y is going to determine on per capita capital. So this is the first message. And the second message is, this equation tells us how over time per capita capital is going to change, right? There are three things is going to determine how your per capita capital change. One is saving. Secondly, depreciation. And the third is population, right? So I forgot to mention one thing, depreciation in some sense reflects to technology, right? Just imagine if your house runs for longer time, or the machine can last for longer time, right? So that's kind of reflects the technology. But nevertheless, I also want to point out here, we have not introduced TFP yet. But let's wait for a little bit. Okay, there's no TFP yet. So far from the technology, from the production function, you can see what matter is per capita capital. All right, so this is the key sense of the equation. Now we move to the next slide. Okay. So just copy what we just copy the key equation, what I just explained to you, delta k equal to S times f of k or y is the same thing, right? And minus m plus d times k. Okay, so this is the key equation to show the dynamics. And then, so what can cause the change in capital labor ratio, but essentially it's per capita capital, it's here, right? So first, it's going to positively relate to per capita saving here. Negatively related to population growth. Negatively related to depreciation. And so this is exactly what I explained in the previous class. Oh, sorry, previous slides. Now, there are two more important information. One is called capital deepening. Okay, so when we have increase in capital, or delta K is positive, we call it capital deepening. So essentially it just says for each individual, they are acquiring more and more capitals. This is called a capital deepening. The more capital each individual have, the higher output they can produce. The other one is called capital widening. So this is when the capital is not changing, delta K equal to 0. Right, so these two notions. Make sure I understand. Now, all right, so now we are going to use a graph to understand how the solo model is going to behave, or use this graph to understand what is going to determine the long run economic growth. Okay, where we start. Okay, so in this diagram, on the horizontal line, we have K, which is capital stock, per capita stock. Vertical line, we have Y, right? Okay, but also you can think about not only Y, so vertical line can be K, let's use plus. So what is K plus? Here's a K you can think about is capital stock today. And the K plus is going to refer to capital tomorrow. All right? Okay. So given this horizontal and vertical, and now we are going to plot a few figures. This line is S times Y, right? And then Y, you have a curve like this. Now actually this is because S is a exogenous given constant value. And then Y equal to what? Y equal to F of K. But F function, as we saw earlier, maybe just go to this slide. Oh, sorry. Here, right? So typical production function like this, you're going to see the relationship between K and Y is going to be a concave function, right? So now we're back to here. So actually on the top, this is a output function or production function. Now S times Y should preserve the shape of this output function. Right? So that's why you have this concave line. This is S of Y. Now what is this straight line? This straight line equal to M plus D times K. Right? So ignore this line for a second. Now focus on this line and this line. Okay, these two lines. A few things I want to emphasize. Number one, these two lines cross each other at here. They cross each other at here. So that's going to give you the long run value of K. That's called K star. Or this is how the economy is going to behave in the long run. Okay? Or you can think about, like in principal class, this is called equilibrium. In the long run, so the economy is going to settle at K star or here. Now let me erase everything and explain to you why we are going to settle at here. Oh, wait, so why I cannot? Okay. So let me explain to you why we are going to settle at here in the long run. Just imagine we are here, right? So if we are here, and then so what you observe is the amount you save is going to larger than the amount you're going to lose, right? Because if you add here, and then so the saving is going to translate this amount of new capital, right? So remember, so we have delta K equal to S times Y minus M plus D times K. Now, if we are on the left-hand side of K star, and this line, this saving line is above this straight line, meaning for each unit of capital is saved here, it's going to exceed the negative force caused by depreciation and the population growth, right? So if that's the case, and then so we are going to move to this direction, meaning so you're going to keep accumulating capital. Now, on the other hand, if we are on the right-hand side of K star, say for example, we are here, and then you're going to see opposite things happens. The negative impact on capital accumulation will dominate. Or in other words, at here, in the margin, so 1 unit capital is going to cause, or 1 unit of saving is going to cause a decumulation of your capital, because this line is above this line. And then so you may wondering, okay, so why we have this line cross this straight line, and why is that? So this has lots to do with the production function. Okay, so here there are 2 things I want to emphasize. This presumably so you should have studied in your intermediate micro class. 1, you have a decrease in marginal productivity of capital. Okay, so the decrease in marginal productivity capital says the curve, this line or this line, start with this line. This line is going to get flatter and flatter. but this line is what is AS times this y. So and then so it must be the case this curve getting flatter and flatter once you accumulate more and more capital. Right? And what that implies is eventually, so this line, eventually this line must be below this straight line. Because eventually you're going to decrease to 0. Right, this is number 1. Number 2, the production function has another property, says when K is approached to 0, your marginal productivity of capital goes to infinity or very large, right? So this just says, okay, so this line must start with above this straight line. Okay, so it is above straight line and they cross it somewhere, so that's why they are going to intersect each other. And then so if you are on the left-hand side of this intersection, okay, and then so this force is going to dominate this one. You're going to keep accumulating. On the other hand, so this negative force is going to dominate this positive force. You start to decumulate your physical capital. And eventually, we are here. All right, so this is how the growth model is going to behave. Okay, any question? Okay, so if there's no question, maybe I can just redraw the graph. Just kind of replay what we just discussed and add a little more information. Oh, shoot. This K is K plus, right? So where we start, so we have this line, M plus D K. This is called negative force, right? Because let's write it here. Delta K equal to S times F of K minus M plus D times K. There's positive force. This is times F of K. So they must behave like this, and due to the following facts, right? So decreasing marginal productivity of capital. So this decreasing as K increase. Okay, and also MPK goes to infinity at K equals 0. Right? Okay. And then so when they cross each other, meaning delta K equal to 0, meaning there's no change in capital stock. And then so we are in equilibrium. Or this is how the long run economy will behave. Right? Okay. So finally, so if we on the left-hand side, so this is K star, if we on the left-hand side, and then you're going to see the positive force that's given by this curve dominate negative force that's going to given by this straight line. And then we are going to see delta K increase if K less than K star. On the other hand, if we are here, opposite things happens. Delta K is going to decrease if K is greater than K star. And why it decrease? Because eventually, so your marginal productivity capital is going to decline. right? So this is going to be dominated by the negative force. Okay, so, or in other words, if we are on the left-hand side of K star, then so we are going to go to this direction. If we are on the right-hand side of K star, we are going to move to this direction. Eventually, we are here. Okay. So now, given this discussion, we can see some implications. Okay. So first, when country has the same state level Y star, Y, poor country are expected to grow faster than rich country and eventually catch up. Why is that? So let's go to the previous graph. Okay. So this just says if you have two countries, one country is here, the other country is here, right? And then the solo model tells us the country start from here. It's going to grow faster than country at here, right? So let's call here the poor country. Here we call it rich country. The poor versus rich is in terms of capital stock. The poor is going to grow faster compared to rich, and why is that? It's because if you draw the graph, it's because for poor country, their margin, their MPK is higher in poor. Okay. The higher marginal productive per capital, meaning, so the positive force in this equation, the positive force in this equation is going to outweigh the negative force in the same equation more. This in poor country, right? Or intuitively, for poor country, save $1, that's going to bring higher amount of capital compared to rich country, right? So, but eventually they are going to converge to here because from this model, regardless where you are, eventually you are here, right? But here the big assumption is you are comparing countries who have the same fundamentals. The fundamentals are in terms of saving rate, population growth, and depreciation. Those are the same across countries. Okay, so this is the first implication. The second implications. Okay, so think about case. Oh, I guess this probably is just explanation. Let me read that for you. Think about the case where one country's income is at Y1 and the other country is Y0. The first country per capita income will not grow, while the second country income will grow. Sorry, so this is essentially just explained, so use the graph. The main implication is given by here. And this implication, and people call convergence. And actually we call absolute convergence. Just says all country eventually is going to converge to the same level of GDP. The other things inside this implication is called transition dynamics. Okay, so essentially it just says eventually we move to the same level like K star as I just showed you earlier. But along this transition, the richer you are, the slower your growth rate. The poorer you are, the higher growth rate. Right. Now, we are going to see some policy implications for this model. Okay. First, let's see if there's an increase in saving rate, how would that affect the economy? Okay. So we start with the same graph, K and Y. Right. And this red line is M plus D times K. And this line is S times Y. They cross each other, that's going to give us their long run capital stock. But then accordingly, you're going to find out the long run GDP. Not just imagine if this country increase the saving rate, they encourage saving, right? It's S prime greater than S. Now you're going to see, so the saving line is going to move up to here. And then they're going to cross with this straight line at a higher level of K, right? So that just says, okay, eventually, so this country is going to move from K0 to K0 prime. And this is going to lead to an increase in output from Y0 to Y0 prime. What this says? This says saving is going to encourage economic growth. And why is that, or how that works? It's saying here because saving is going to, let me write down, saving is going to lead to capital accumulation. But this capital accumulation is going to allows us to produce higher amount. All right, so this is the first implications. I mean, sorry, the second implication maybe. Now here we have examples. Okay, so if you compare Nigeria and Hong Kong, okay, and wait a second. So we should have another. So over from. Sorry, so these 250s should be Hong Kong, but in Nigeria, so the number is smaller. But eventually you're going to see, so the per capita GDP present very different patterns, right? And similarly, you can compare Gambia versus Japan, right? And higher growth rate is going to lead to higher GDP growth, right? Now, we can look at what happens if there's increase in labor force. So I guess maybe we can take a break and then so we coming back. So for the two students, please send me your Excel file. Let me just read over the break and then so we can discuss. I think I received, did I receive Jordan? I received Jordan's data. The other one, Jimmy, so, wait, so they are received both? Okay, I think I've received both. Okay, so why not we take a break and then so we coming back and I just explain to you the data. Is that okay? Are we here?
Yeah.
Okay. Okay.
That's
See
good.
you probably like in 15 minutes. Let me just read your data. All right. Thank you. All right, so are we here?
Yep.
Okay. Oh, sorry. Let me just close this one. Okay, so this problem is, let me just close this. Just give me a second. So there's an issue with my computer. Why? All right, so let's look at this one. Okay. Overall is correct. So there's one sense. That was what I was trying to explain. So first you need to calculate TFP. So this is missing. Wait, okay, so why? Okay, so you need to calculate TFP. So for example, so you calculate South Korea's TFP. So what are you gonna do? So let's say for example, so you look at 1980, and then so the TFP equal to real GDP, this number, divided by, let me just make it bigger. Wait, so. Oh, where's my number? Okay, so this is this number, right? So the real GDP divided by this number, capital stock. Okay, divided by capital stock, raised the power of 0.33, and then times this number, labor supply. So what's how we get this number? Anyway, so you oh, wait a second. Right. Times, let's say, let me just copy the number, 67453 raised the power of 0.66. So this is how you get TFP. All right. So you need to first you need to calculate TFP separately. So what that means is, okay, so you find the TFP for each year, each country, right? And then, so in this equation, what you're trying, so this equation kind of are verified. What this question says is, so if you find the TFP following the formula here, and then by construction, the following should be correct. So the GDP growth rate is called G of GDP, right? So G is a growth rate. So the must equal to 0.33 times. Oh, wait. So this is not working. Let me just write it here. GDP growth rate equal to 0.33 times the growth rate of capital plus 0.66 times the growth rate of labor, and then plus growth rate of TFP. So that's what we, so this is supposed to be to correct, and this is what you need to verify, right? So let me repeat. First, you calculate GDP here, and then so you're going to verify. So this equation is correct. This equation. Is this clear? Jim, or James?
Yep, that makes sense. I just need to get the real amount of the TFP, and then that equation below just verifies it. Yep, that makes
Right.
sense.
Right. So just verify, not instead of so now that you find the TFP right through here, you just verify. All right. Okay. Now we back to the other one. It's here, I believe. So yeah. So now look at it here. So they're like small number, right? And why we have such small number? The reason why we have such small number is because just look at it here. Look at the GDP. And then so, GDP is okay. So look at the labor. What's labor number? Oh, maybe it goes here. Oh, maybe just look at here, right? So GDP. This is GDP, and this is labor hours, right? So what do we have here? So TFP. Really, there's no unit. Okay, if you divide this number by, I don't know, let's just remove these 4 zeros. Or somewhere. No. Okay. But anyway, so what I'm trying to say is, so you can change the unit. You change the unit such that the number you calculate here is close to 1. So it's easier to read, easier to compare. All right. But at the end of the day, so really matter is, let me see, what is, all right. So yeah, so this is good. So what really matters is this number. That's the growth rate. Or other things matter is if you use the same unit, you compare one country in 1992, let's say for example, okay, let me see what data you have. Oh, China, India. Okay, yeah. So at the end of the day, if you use the same unit or you calculate TFP following the same unit across countries, and then so you can compare, say, oh, so this country versus the other country, so which one has higher TFP? But clearly you can see this is not easy to compare, right? So if you somehow you change your unit such that this becomes, so let me see, there are 4 zeros. No, yes, there are 5 zeros, there are 4 zeros. And then so this just says, okay, so this country has 4.29 and this has 12.5. Right? And then that become easier to compare. Does that make sense to you, Jordan?
Yeah, I understand.
Okay. So, but other than that, so I think so looks good, looks perfect. Right? Any question from the rest of the students? If not, now let's just back to this class. Let me leave this meeting. All right, so this is where we left, right? Okay, so what we have discussed essentially is a solo growth model, right? And in this sense, solo growth model, just trying to understand what determines the long run behavior of the economy. And so in this sort of growth model, what matters in terms of long run economic growth is largely hinged on capital. But remember, this is K divided by L, or per capita capital, right? To summarize, so what determines the dynamic of the model? So essentially, this is the equation: delta K equal to S times Y, and we plug in Y equal to F of K minus M plus D times K. Right. So this is how this is what determines the behavior of the economy over time. Right. And then so in the first part of today's class, I explained to you, so when delta K equal to 0, we enter some long run behavior. If K is too small, and then the first term is going to dominate the second term. The capital is going to accumulate. If K is so high, and then the second term is going to dominate the first term. And then the economy start to slowing down, right? And that's why eventually we meet in the middle, like here, or like here, right? Okay, so, and we also talk about if there's an increase in S changing from S to S prime, how the economies behave. Now let's see what happens if there's increase in labor force. Okay, and then you're going to see, so this line is going to move upwards. Now you're going to see the capital stock in the long run is going to decline, and accordingly, so the output is going to decline. Right, and why is that? It's because, so if you only have a population growth, okay, then this population growth is going to reduce the per capita capital stock if nothing else change. Now, essentially, you're going to see the capital start to widening, or the capital starts to be diluted by larger labor force. And similarly, if there's a D increase, that means the capital depreciate faster. Similarly, so we are going to see the GDP growth slowing down, and similarly, we are going to see the economy is going to decumulate capital. Now, this is another implication for this model. Now, we are going to introduce technological change, right? So essentially, we are going to introduce TFP inside this model, all right? So, but how we are going to introduce TFP? So there are different ways. So you can either write y equal to TFP times f of KL. So essentially, just multiply a constant in front of a production function we have discussed so far. Or alternatively, you can write this way. So y equal to f of k, but t is going to augment it, or this here, t stands for TFP, augmented with labor supply. But remember, we have constant return to scale. So this is going to be equivalent to write like here, right? But nevertheless, so T times L, we call this effective unit of labor, or sometimes we call efficient labor supply. The same thing. Just essentially just augment the labor with the level of TFP the economy have. Right. So now, how would that change the discussion we have? Okay. So if we have a technology progress at a level of K, okay, and then so we are going to see an equation like here, right? But however, this KE is efficient capital stock, or in other words, KE is defined by here. All right, and similarly, Y is defined by Y divided by T times L. Okay. Now, what are we seeing here? And again, similarly, so you're going to see, so this line with this line is going to jointly determine the long-run behavior of the economy. They are across each other. That's going to determine how the economy is going to behave in the long run. And accordingly, so you look at the GDP or output. Right. Okay, so the lots of things we are going to do with this solo growth model is going to similarly do the growth accounting, right? But this growth accounting, essentially, it just formalizes what are we supposed to do in the homework one, right? And then you're going to see equation very familiar, so let's just write it here. Right? So on the left-hand side, you have GDP growth. And the right-hand side, so delta K divided by K, so this is capital growth. So this is labor growth. And we can ignore this for a second. Right, so there's just other factors. Think about, like here's, we consider resource, like land and other things. All right, and what is A? A is TFP growth, or the growth rate of A. Right, and then this is exactly what we have used for homework 1. Okay. Right, here is an example. If we assume alpha K 0.2, alpha L equals 0.7, and then so you have alpha R is other resources, 0.1. So those are the growth rate. And then, so we suppose have this equation holds. So this observed GDP growth. So GDP growth coming from technology growth, and this is the capital growth. This is labor growth. Wait, apologize. What happened? Okay, no, so this is capital growth rate, and then this is labor growth rate. This should be a plus sign, right? So this is A, K, L, and finally this R, right? So they add together gives you the GDP growth rate. And then in your homework, so you may want to analyze the contribution of each component. So if you give them the capital contribution to the GDP growth is 0.01 divided by 0.052. So this capital's contribution. And TFP or technology, it's called TFP. Its growth on GDP is going to be 0.02 divided by 0.052. Okay, you can do the rest for labor and the resource. All right. So now to summarize the sort growth model by looking at the shortcomings or what the model fails to explain the reality. To understand that, so that we can think about how we can improve the model. Right. So first, this model doesn't provide explanation of a change in technology. A is exogenous given. Actually, so in most of the discussion, we even did not talk about A, right? But actually, A is exogenous given. Nothing tells us where does A coming from and why A may change over time. This is first. And secondly, so this model suggests capital should move from rich country to poor country. And why that is because poor country, their labor is abundant and rate of return on capital is higher. Or in other words, let's just think about the graph. So the rich country probably is here, poor country is here, right? So in the poor countries, the slope of this curve is higher, meaning the rate of return on capital is higher, meaning there are more reward of investing, but eventually means the growth rate is higher in poor country. And then the implication for that is, so the capital should move from rich country to poor country, right? But unfortunately, in reality, the resource move from poor country to rich country. Okay? So this is one of the shortcomings of this model, and closely related to this part is this model suggests eventually all countries are going to catch up with each other, or as I explained to you earlier, it's called absolute convergence. meaning regardless where you're from, eventually, so all countries going to enjoy the same level of GDP. Okay? But again, so this did not happen in reality. In reality, we do have a conditional convergence. Conditional convergence. Okay? Instead of all countries move to the same level of GDP, okay, so we only see a convergence among countries who has similar institution, who has similar technology. So for example, so if we compare Germany with US after World War II, or if you compare Japan with the United States after World War II, we do observe convergence among those countries. But if you compare United States with Mexico, or if you compare United States with Brazil, okay, so their gap was significant, and it's very persistent. Right? So this is called conditional convergence. But then so we need to explain why there's no absolute convergence as the model suggests. Okay? A simple fix for that is, so people say, okay, so you may think about there are two countries, they are different in terms of technology. Meaning, so one country has a curve like here, but the other country, so maybe they have a production function like this. So meaning, so they are eventually they are going to converge to different level, right? Or can you think about this is a group of country like Latin America. This is a group of country like OECD, those rich country, right? But then, so this is going to circle back to the first point. Why these two countries have different TFP? Where does their TFP difference coming from? Right? So, and lastly, so in reality, poor country, I mean, it's extreme poor country, or most of the poor country, so their growth rate instead of faster compared to a rich country, so their growth rate are slower. Okay? And then, so we need to understand why. But that's going to be the next slide. So close this slide. Okay, so the big shortcoming of this model is A is exogenous given. You can adjust A by reconcile lots of discrepancy between the theory and the model. So for example, we can say like different country has different level of A. So then they're going to converge to different level. Also, you can say, oh, so rich country, so they not only have a higher level of long-term growth, they also enjoy constant growth in A. Meaning, so they're going to keep moving up. Right? And then so you can say, okay, so the poor countries, so they do move up with the A, but in a slower speed. So that can potentially explain why rich country, instead of grow slower, they grow faster. But everything hinges on how you're going to make assumption regarding to A. Okay, so this theory is completely silent on where does A coming from, how A grow, and how the growth rate or why the growth rate differ from country to the other country. Okay? So that leads to new growth theory. So that's built upon the solo growth model as we just finished. Okay? And the key things here is they are going to provide a theory that explains the A, first A differs across country. And the secondly, A grows over time. But we need to understand why it grows and why it differs. Okay. So I'm going to quickly run through a list of new growth theory that explain the change in A. The first one was proposed by Paul Romer, and he won Nobel Prize last year. And in his paper, Increase in Return and Long-Run Economic Growth, he proposed a theory. So in this theory, so more capital not necessarily means diminishing return, like we have seen in New Class Growth model. Right? So instead, so the more capital you have, the business may have bigger incentive to explore new technology or to develop new technology. Right? And then so eventually, so instead of diminishing return, so they may have increase in return. But how they can develop new technology or how they can have better technology once they acquire more capital. The micro foundation or the story inside the black box is called spillover effect. What is that? Let's just think about, so you live in, you have a startup or you have a business. Your business in a rural part of the country versus your business is in Silicon Valley or New York City, right? So the business, the founder, everything is the same, but you have different location. And the location is just a symbol or just a parable. So the location is referring, so you have different environment. In Silicon Valley, you have more similar firm. They have better technology. They have better know-how. So those better technology, better know-how is going to naturally spill over to you. Or we could, one firm can leak to other firms. At the start off, you can mimic the other business in the field, or easier to mimic compared to in the case if you live in a rural part. Now, so this is a story of spillover. And this spillover of knowledge can cause increase in return on capital. Because the more capital you have, the more overall knowledge we have. And then the stronger the spillover. So that leads to constant increase in A or TFP. Right? And this also explains so why capital move to the place with more capital. Or think about the capital, the talent, the capital move from rural part to big city. This is because in big city or in the tech hub or financial centers, so there are stronger spillover of knowledge. And then, so that's going to attract more people. So this is the first theory proposed that address this exogenous A. Okay. And similarly, Lucas, he also won Nobel Prize, but back in 1990s. He had similar story, right? So look at here, so in the production function, so we have regular A, L, so let's ignore R for a second. R, just think about like a resource, like land. And he has human capital, right? And what is human capital? Okay. So human capital is the technology know-how. It's the institution we have inside the business. So by including the human capital, so we change the story of decreasing marginal return. So essentially, you can think about, rewrite this as Y equal to, let's use Y height, okay? Y times H delta. And this Y is what we have in previous solo growth model. And in Lucas' theory, essentially it says, besides the regular things solo model talk about, human capital plays a role. And human capital does not subject to decrease in marginal decrease in return, just decrease marginal return. And because human capital is different from physical capital. So human capital different from physical capital in a sense, there's some externality. Right? So you have spillover, as I explained in previous slide, and human capital has no rivalry. What does that mean? It means, so if I'm using the computer, this is considered a physical capital, and then nobody else can use, or at least the second person who uses a computer is going to have a reduced utility or reduced productivity. But now, so if we are talking about this series today, and everybody can do the same things, so that's human capital or the knowledge, right? So the knowledge can be accessed by everyone at the same time without the reduction of its productivity. So this natural leads to this property of human capital leads to human capital breaks the decrease in marginal return, right? So that eventually leads to a break of this production function, right? Because in the original production function we discussed in total growth model, we are going to see a decrease in marginal return. But now with human capital, and then so we won't see that phenomenon. All right. Okay, so I guess I should stop here for these chapters. For the rest of the things, maybe you can read yourself. There are a few things you can read yourself. Right, so this you can read yourself. Now I'm going to move to a new chapter. All right. Okay. Oh, by the way, so the homework tool is coming up. So to understand the solo growth model, it's better to work on the homework tool. All right. So by working on homework tool, you should have a better understanding of the solo growth model. So, and then so we can discuss the homework tool maybe next class. Right. So now we are going to move to a new chapter. Okay. So this chapter is about inequality and poverty. Okay. Here are the list of questions we are going to address in this chapter. How can we best measure inequality and poverty? So this is a measurement. And the second is what or why. Why is bad? Or why should we care about extreme inequality? Okay. And the third, we need to understand who are these in terms of people living the downstream of the distribution, and the people who considered lives in poverty. Okay. And then finally, so we can think about policies that to deal with inequality and poverty. Those are the questions we will cover in this chapter. But first, let's briefly talk about why should we care about inequality. Okay. So from the discussion we have so far, I hope you understand that growth is a necessary condition for improving living standard. So living standard is a better concept compared with growth in terms of understanding development. Okay. But the growth is necessary, but growth is not a sufficient condition for improving living standard. And if we look at inequality and poverty, which is the main topic of this chapter, you will have a bigger picture or better picture regarding to living standard. Right? So this is because the following things. Right? The increased output maybe used to increase the power of the rulers or the elites of the society. If that's the case, so you have growth, not necessarily means improve the living standard of everyone. And secondly, so the increased output may be used for reinvestment, right? Not necessarily goes to the ruler, but then so the policy asks everyone to tighten their belt, save more, increase investment, hopefully has higher growth. And this happens in Soviet Union, right? And so with that, you will see higher growth, but most of the population will suffer, right? And lastly, so the richer may get richer, rich may get richer, and the poor get poor. So this happens in most advanced economy these days, right? And so we are going to have one slide to explain why this happens and what we can do. But this just tells you, so growth is not a sufficient condition for improving standard, improving living standard. It is necessary, but it's not a sufficient condition, right? So there is a short video, so let's just wait towards the end of today's class to show you, right? So once we towards the end, so I'm going to show you that. So first, let's just look at some concepts or measurements. So now in this second part, I'm going to explain to you how we are going to measuring inequality and poverty. Right? We start with income distribution. Okay. So income distribution, first is a distribution. And secondly, this is a distribution about income. But this distribution has different way to look at distribution. You can look at a functional distribution of income. What does that mean? Means, okay, so you look at income. Some of the income goes to labor. Some of the income goes to capital. And some of the income goes to others, right? Including maybe land, including maybe intellectual, right? Here, because this physical capital, sorry, here capital typically means physical capital. And others may be like intangible. Okay? Think about intellectual properties, right? And then so here we are going to look at the distribution of income through functions. And why this matters is because later you're going to see if we look at the general population, depending on your economic social status or depending on your characteristics, you relies on more, maybe more on labor, or somebody else may rely on more on capital income. Okay, but that's going to naturally translate into further inequality, right? Because over time, the return to labor or the income grows on labor or income grows on capital or income grows on other type of income varies widely. Okay, so this is the first way to look at distribution of income. The second way to look at distribution of income is by incomes among households. So for example, the poorest households, poorest 20% of households, this is in the United States. So their total income is 5% of the total income the society has. If we look at richest 20% of households in the United States, so they are going to make 45% of the total income, right? So this also matters. Matters in the sense, so if this number decline and this number increase over time, that's going to exacerbate the inequality. But actually this is what happens in reality. And furthermore from here, so we can provide or we can find better policies. Okay, so policies to reduce inequality. So for example here, right? So, because you know the poor guy so their income share is lower, and the rich person, their income share is higher. And then, so the policy should transfer some of the income from rich to poor. But of course, we need to factor in, so this transfer may discourage innovation, may discourage entrepreneurship, right? So here, just give you a sense how the distribution of income look like. So this is by, like in the second case, oh, sorry. So this is by personal distribution of income. Okay. So this is 2010 estimates. All right. So how we read this figure? So on the far left, so those are the households whose income is below 5,000. They make up about 3.5% of the population. To the far right, we have households who makes over 250,000, 250K per year. So they are about total, I mean, if you include households make over 200K, remember this is 2010. So they are about 4% of the population, or 4% of the American households has an annual income of more than 200,000. All right, so this is how the income distribution looks like in US. This is one way to look at. The other way to look at the income distribution is the income share of the top 1%. Right, so their income share was very high in 1930s. And then they experienced a long decline. One of the long decline coincides with tax increase. But in 1980, so they experienced an increase. So this increase coincides with two things. One is tax cut by Reagan. And secondly, by technology or IT innovation. Right? So I'm not talking about what explain this, I just show you the facts. And furthermore, we want to understand why this matters to the economy and what kind of policy we should follow to deal with the potential damage this can cause to the economy. And I also want to emphasize here, so we look at the US, but this is true across countries. And it's probably even worse in developing countries. Right. So here we just look at the numbers. These numbers just, it's a different way to see the figure before. Right, so I'm gonna skip here. And also I'm going to skip that one. So those are just data, so just give you a sense. Now, all right, so maybe I can say a little bit. No, so we are not ready to look at that yet. So, okay, so now we are going to look at the measurement of inequality. To understand the measurement of inequality first, so we need to draw a Lorenz curve. So what is Lorenz curve? So the Lorenz curve, what you need to do is you rank every individual income from lowest to highest. Like 0 means someone who stands in the 0 percentile. And 100 means the richest person in the economy. And if you are here 60%, meaning so in the economy, there are 60% of people poorer than you and 40% of people richer than you. Okay, so this is the first step. And secondly, so for each percentage, so if you get 10%, you are going to find out what is the total income of those 10% of people, and what is their share as the total income of the society. And here, significant means 3, just means the poor is 10% of the population. So their income is only 3% of total income. And by construction, so here, so the 100% of the households, they're going to share 100% of the total income, right? So this is how we get the Lorentz curve. Now, give you another example. If you look at 60, and 60, say for example here, this number is 27, meaning 60% of the poor is 60%. Their total income is 20%, 27% of the total income we have in this society. Okay, so this is Lorentz curve. Now, given this Lorentz curve, we can construct a measure for inequality. But to understand that, so we can look at 2 possible distributions. Right? A is a relatively equal distribution, and B is a relatively unequal distribution. Okay, to help you understand why B is relatively unequal, think about extreme case. Okay, instead of this line, now let's say, for example, so you have a Lorentz curve exactly equal to this 45-degree line. What does this mean? If we have a Lorentz curve like this, just means everyone has the same share, same amount of income. How to understand that? So if we have Lorentz curve here, then it says, okay, 1% of the household, poor is 1%, have 1% of income. Poor is 10%, have 10% income. Poor is 30%, have 30% income. And that just means every individual has the same income. So that is absolute equality if we have this line. Now, when you go to other extreme, if we have a curve, if I have a Lorentz curve, you have a horizontal line, and up to here, you suddenly increase. What this means? This just means the 10% of households has 0 income, 30% 0 income, 40% 0 income, 90% 0 income, 99% 0 income. There's one individual has the entire income. Right? So that's absolutely unequal, because this one person has all income and nobody else. Right? Hopefully you can see the difference. And then so here we just move this line towards this kernel, right? And gradually you can see, so this becomes less and less equal. Now with this comparison, we are ready to have a Gini coefficient. What is Gini coefficient? We just use this region, the area of this region, divided by the big triangle. Right, it's A divided by A plus B. Right? Now go to the previous slide. If we have the Lorentz curve at this straight line, and then so A plus B equal to 0 divided by some number, meaning so the Gini coefficient equals 0. Right? On the other hand, here, so A divided by A plus B, so that's going to equal to 1. Right? Because B is collapsed to 0, right? Because this B just collapsed. Okay? And then So you can see the Gini coefficient is between 0 and 1. 0 is absolute equal. 1 is absolute unequal. Okay. Now we can look at examples to see how we calculate. So first, how we draw the Laurent curve, and secondly, how we calculate Gini coefficient. So there are two countries. Let's start with country 1. So this is their distribution. The poor is 25%, they have 5% of income. Okay? So this is country 1. The poor is, wait. All right, so poor is 5, so this is income. Poor is 25%, they have 5% income. The next 25%, they have 5%. So that just means the poor is 50%, they have 10% of income, right? So let's go to here. Now, the next 25%, they have 45%. So meaning, so we add them together. The poor is 75%. They're going to have 5 plus 5 plus 45. That's going to be 55. And lastly, so if you include everyone, right? So they are going to have 100%. It goes to here. So this is how we end up with this. Oh, here, right? So this is 4 points. This is for country 1. And similarly for country 2, we can draw the country 2's Laurent curve. Let's use triangle. So this point, this point, this point, and this point, right? So they have 2 different Laurent curve. Now, we are ready to calculate their Gini coefficient. Start with country 1. Okay, so country 1, let me highlight, it's given by this line. This country line, right? And then so what we need to do is find out the region in here, divided by the big triangle, right? So Gini coefficient, let's call it Gini 1 equal to what? A divided by A plus B. But for B, it's straightforward, right? So this big triangle equal to what? Equal to 1/2. Now we need to find out A. But in order to find out A, so the best way is what? Is use the big triangle, subtract the big triangle, subtract this part, this rectangle, and this triangle. Right? So that equal to 1/2 minus, now start with smaller one. This smaller one, because this point we already know is 10, right? The smaller one equal to 1/2 times this, because this is 10%, 0.1, this is 50% times 0.5, right? So 0.05 and equal to 0.025. And this rectangle equal to 0.5 times 0.1 plus 0.05. And finally, this bigger triangle equal to 1/2 times, because this distance is 90%, 0.9 times 0.5, right? So that's going to give you 0.0225, I believe. Okay, and from here you can calculate the Gini coefficient, right? So let me erase. Okay, so that's how you calculate the country 1 Gini coefficient. And similarly, you can calculate the country 2's Gini coefficient. All right. So that's the answer. So country 1, you have a Gini coefficient 0.4, and country 2 is 0.3. And here the unit is different, right? So this 5,000 essentially just use 100%, right? What I just calculate is just treat this as 1, right? Make sure you understand this. You make sure, so there are 3 parts, right? So this is the first small triangle. This is the second rectangle. This is the third triangle, right? This is a big triangle, right? Now, so we can look at the Gini coefficient in real world, right? So by the way, so this number, you should understand this is percentage. Because Gini coefficient between 0 and 1, this is percentage. Higher the number, more inequality. Lower the number, less inequality. Okay. From here, a few things you should pay attention. So you should notice the number is smaller in this group of country. And this particularly compared with United States, Singapore, and Hong Kong. And why I compare this group of country with these 3 is because in terms of GDP, they are in the same group or similar group. Right? They are considered as advanced economy. But you can see, so their Gini coefficient are quite different. Like US over 40%, Singapore over 40%, Hong Kong 40%. But among those European countries, or including Japan, so it's below 30%. Okay, so there are many reasons. One big reason that explains the difference is because those countries has different tax system. As you're going to learn later, so they have more progressive tax. Progressive means higher income pay higher tax, lower income pay lower tax. That helps to bring down the inequality. This is number 1. Secondly, I want you to pay attention to these countries, or maybe include India, right? Or yes, definitely you want to include China, Russia. So these 1, 2, 3, 4, 5, these 5 countries are compared with the rest of the samples. Average, their Gini is higher. And how they are different from the rest of the sample. So they are considered less developed. Right? And then so clearly you can see there's a relationship between level of economic growth and the Gini coefficient or inequality. Okay. Now we are going to move to a different measure that understands inequality. It's called poverty. Right? Because the Gini coefficient only tells you how inequality we are, but the Gini coefficient doesn't tell you how bad are those poor people. I mean, in terms of suffering, right? Okay, so that's why we need to look at poverty. Okay. So in order to measure poverty properly, there are following properties we need to satisfy. First, anonymity, meaning so this poverty shouldn't have a label on someone, shouldn't have a name on it, right? And secondly, it must be independent of the population. You cannot say, okay, so this population or certain group of the population, their poverty but not others, right? And the third, it must be it has monotonicity, meaning, so this poverty is increased with income or decreased with the income, right? And finally, so this poverty can reflect the distribution of income, right? So now let's see some poverty measures. Oh, sorry. So there's one slide we need to see. So how we are defined poverty, right? So poverty is defined as a condition below the minimum accessible standards. And the poverty line is measured by income, and it varies from one country to the other country. Let's use United States as an example. So this poverty line or poverty level change over time. And if you look at the same year, it's different across region, right? Okay. Yeah. Okay, so we can come back to this later. Okay, so the first, let's just see how we measuring poverty. The easiest way to measure poverty is look at head count. So we use age, which is the number of people who considered are poor, meaning they live below the poverty line, divided by N, which is the population. Right? And clearly, so this age divided by N satisfy those four conditions. Because here you cannot tell who, I mean, because this age is just a number, doesn't tell you who are they. And secondly, this is going to change with the distribution, right? And the third is going to monitor, right? What is the fourth one? Let me see. I forgot the fourth one. Population. All right. So lastly, it doesn't depend on which population you should look at, right? It just give you a number. Okay. But however, this index only tells you the fraction of people who are below poverty line, who are poor, but doesn't tell you how poor are they. But at least this is better than Gini coefficient, because Gini coefficient doesn't tell you who are suffering in terms of poverty, right? Here at least tells you certain fraction of the population they are suffering, but this is not good enough. Now we move to the second one. We look at poverty gap. So the poverty gap is just measuring the total gap. The total gap. It means the total income gap of those people who consider as poverty. So this summation is from 1 to 8. Those are who considered as poor, or they have income below the poverty line. We sum them together, just tells you, so as a group, how much are they suffering? Their suffering is measured by the gap between YP. They are below this gap, right? So they are YI here. Okay, so now we can have a graph to understand. So this line is income from 0 to 1%. They're just like a log curve. Sorry, this is not log curve. This is distribution. Right? So this is the poorest guy, this is the richest guy, and then their income. And then we have a line. This is a line to define. So if you are here, if you're below, then you're considered poor. The first measure we have is head count, and then this head count just tells you have 0.5 or 50% are poor. But then, so if we just measure in this gap, and particularly if you compare country A versus country B, both countries have the same head count, which is 50%, right? But certainly country A, the poor suffers more than country B, because the poor in country A are poor compared with country B, right? Okay, so I'm going to start with a new discussion here today. So now let me just show you the video we skipped, right? So now let me use my use my laptop, because when I share the screen with you on my pad, it seems that always is an issue. Just bear me with a second. In the meantime, let me know if you have any question.
Professor,
Yes.
if we submitted our homework before class today and we need to go back and make changes, can we do so and resubmit it before Wednesday?
Yes, if there's the technical issue doesn't allow you to do that on Canvas, you can always send me email.
Okay, thank you.
Okay. Just bear me with a second. So let me find out the link. How many of you have already submitted your homework?
I did.
I did too.
Yeah, feel free to make change, and if there's the issue, just send me email, right?
Okay, thanks.
Okay, let me kill this one.